I'm supposed to cover is kidney and neuro involvement. However, upon looking at this, I think it'll be much easier to understand almost every type of system involvement if we back up and take a look at some background information on hypersensitivity and the pathogenesis of lupus. So you remember that we have 4 basic types of hypersensitivity. There's going to be type 1, 2, 3, and 4. The HELP Hippo gives a useful mnemonic to help you to remember these. You just do A, B, C, and D. A is allergy. B is bad blood. I'll explain this. C is going to be complex, as in immune complexes, and D is going to be delayed. So the key characteristics in a type 1 hypersensitivity reaction is that you're going to have free antigens, free foreign antigens, and so I'm going to write foreign under here. And you're going to have a bound antibody, and it's going to be IgE. And what's it bound to? It's bound to a mast cell. The other question is, how does that IgE get there? IgE gets there probably from an initial exposure. So it's never the first exposure, but it's an initial exposure. You're not going to have any type of allergy the first time you come in contact with the allergen. So the initial exposure is going to cause the CD4 helper T cell to overproduce IL-4. So you're overproducing IL-4 for some reason, and so the exact reason is not known for sure, but for some reason we're overproducing IL-4, and overproduction of IL-4 causes B cells to produce IgE. So I have my mast cell. It's coated in IgE. It comes in contact with the antibody or the antigen, and antigens get bound. Everything gets cross-linked, and all of a sudden, what's causing the problem? Histamine is being released. So histamine release, we have all these histamine granules. They get released, and that causes most of the problems with the type 1 hypersensitivity. It's important to note that because type 1 hypersensitivity, they are foreign antigens, they cannot be classified as autoimmune. But the next 3, type 2 through 4, can all be autoimmune diseases. With a type 2, your antigen is going to be bound. So you have a bound antigen, and it is a self antigen. So it's a bound self antigen. And there are some situations where it's going to be, like, these can be drug-induced. For example, you can have drug-induced autoimmune hemolytic anemia, and that's typically because the drug will alter one of the self-proteins on a blood cell surface, and so it's still a self-antigen, and however you want to classify that. And I haven't been able to find any example where it is purely a foreign antigen. So for right now, I'm going to say this is a self-antigen, and it is bound to basically to the surface of a cell, or it could be to the surface of anything, but we'll say a cell surface. And you'll have a free antibody, a free immunoglobulin. It's floating around. It's not attached to a mast cell. It's not attached to anything else. It's just free floating. Now that could be IgM, it could be IgG, and so you see basically the free floating antibodies is what we're looking at. The problem with type 1 was histamine release. The problem with type 2 is that we have opsonization. So opsonization. And so with the opsonization, when you have antibody complexes binding on a solid surface, that gives a spot for complement to go and bind and to be activated. So you're going to activate complement. I'm just going to put comp, and you're going to have phagocytosis, and from phagocytosis, you're going to have these cells being destroyed. You're going to have inflammation. You're going to have all of the typical inflammatory problems. But typically, not typically, but usually, these kind of things will be focal. And so let me give you a few examples. Example number 1, Myasthenia Gravis. We just talked about this, I think it was Thursday, or maybe it was Tuesday. It was one of those days. We talked about Myasthenia Gravis as being an antibody, free-floating antibody, that goes and binds to a bound antigen. That bound antigen is the acetylcholine receptor at the neuromuscular junction. So with Myasthenia Gravis, 3 things happen. The first thing is that the antibodies will fix complement. So they'll fix the complement, and it will damage the postsynaptic membrane. It can increase internalization of those receptors. And the last thing is I'll just write it up here, it will block ACH binding. So in this case, we don't get the phagocytosis. So remember, this stuff right here is not the rule. It's just like this is typically what happens. These over here are the rules of what type 2 is. And then here's a specific example. So type 1, free antigen, bound antibody. Type 2, bound antigen, free antibody. With type 3, immune complexes, if you just remember immune complexes, you'll be able to remember this. The rule is you're going to have a free antigen, and you're going to have a free antibody, and that says antibody. I'll just put an alpha. And the problem with this one is that complement and phagocytosis don't get activated early enough because these immune complexes that happen are very small. So here we have my free antigen, and then I have this antibody that it gets attached to. Now it might just get attached to one antibody, or it may be that several antibodies are attached up and linked together. And so you can have a larger complex, you can have smaller complexes. But the problem is that these complexes still don't get big enough to settle down in one place long enough for complement to be activated and phagocytosis to take place for opsonization. And so they float through the blood, and when they float through the blood, eventually they get to capillaries, and when they get to capillaries are small and they filter out these kind of things, and they get deposited. So you get deposition. That's the problem with this, deposition of immune complexes. And the big one that's known as rheumatoid arthritis, or RA. Rheumatoid arthritis, basically you get rheumatoid factor bound to antibodies, and those get deposited in the joints and cause problems. Anytime there's immune complexes being formed, you're always wanting to think about the thing that filters all of the blood, which is the kidney. Kidneys almost always get damaged, not always, but almost always get damaged by type 3 hypersensitivity. Now, the thing to point out with type 3 hypersensitivity is that it can be self-antigen or it can be a foreign antigen. So by definition there, or by deduction there, you can say that some type 3s are not autoimmune and some type 3s are autoimmune. Now, the last of the hypersensitivities is type 4. The mnemonic for that is delayed, and I like to think of it as T-laid because it's basically mediated mostly by T cells. It's cell mediated. So whenever the CD8 or the cytotoxic T cells go and destroy other cells, that's what's going on there. Whenever the MHC class 1 of, say for example, an organ transplant is recognized as being false, that's going to take a little while. It's delayed, but after a little while of those CD8s figuring out where things are and what's wrong, it's going to kick that thing off. It's going to reject it. And so this is the only one of the hypersensitivities that is not antibody dependent. Antibodies are not involved. Now I'll give you a few examples of this. So polymyositis, or PM, would be one example where you have CD8 positive T cells attacking the muscular and vascular tissue around muscles. You also have Sjogren's disease. I'll just put SJ for that. Sjogren's disease is where the parotid gland, or basically the serous secreting ducts, get attacked by CD8 cells, and that would cause you to have dry mouth and dry eyes. Another one that we saw last year in 1 year was Guillain-Barré. Guillain-Barré. And now Guillain-Barré, you'll remember, is basically a cell-mediated attack on the Schwann cells of peripheral motor nerves, and it's usually due to cellular mimicry from something like Campylobacter jejuni and a few other diseases. We don't know 100%, 110% for sure that it is that Guillain-Barré is a type 4, but what we do know is if we take the T cells from an animal or from a person that's infected with Guillain-Barré, or that has Guillain-Barré syndrome, that's not an infection, but it's usually caused from an infection. We take the T cells out of those and put them in other animals, they end up getting demyelination as well. So it's probably a type 4 hypersensitivity, cell-mediated, and end of story. So how does that get us to SLE? So SLE, systemic lupus erythematosus, is a combination of two types, type 2 and type 3. It is a combination of type 2 and type 3, and so we're going to see features of both type 2 and type 3. So we're going to see features of these bound antigens being attacked at specific locations. We're also going to see deposition of immune complexes in various places where you would see the capillary beds and the filtration system. Now, I'm going to make it really simple, because understanding why are all these things happening, really just you need to understand the basic idea of what SLE is. SLE is the mothership of autoimmune diseases. It is the autoimmune version of syphilis. Now, why did I say that? Syphilis is known as the great imitator because that one infection can look like so many other diseases. So it's called the great imitator. And lupus is also it can imitate tons of other diseases. Now, if you look up great imitator, just Google that, and you go to the Wikipedia page, you'll find out that there's probably 20 medical conditions that are known as the great imitator, and lupus and syphilis are only two of those. But if that helps you to tie it together, lupus, syphilis, one's an STD, one's an SLE. And the reason lupus can be the great imitator is because it is a failure of the immune regulatory system. So what is it? SLE is a failure. What is it? It is a failure of the regulatory system. So and this is only one of 20 competing theories, but it's the top theory right now, is a failure of the immune regulatory system. And because the regulatory system fails, you can basically become hypersensitive to any damn thing. Now, what causes the regulatory system to fail? Nobody has a good answer. But what we do know is that there are genetic factors, there are environmental factors, and there are epigenetic factors. Let me spell it right. Genetic factors, and there are infectious disease factors. There are all kinds of factors that are associated. Association doesn't equal causation, so that's where that goes. One thing is that the genetics, there's a gene on the X chromosome. I think it's called the TREX gene. Women have 2 copies of this. This gene's associated. So a polymorphism of this gene is associated with SLE, and so women are twice as likely to have this polymorphism, and women are 9 times more likely to have SLE. So maybe that points to genetics, maybe it doesn't. And a various mutation in the HLA-DQ, so the human leukocyte antigen, or the we'll call it the MHC. It's the DQ subtype. A polymorphism in that is an association with SLE. Certain infections are associated with it. So what all this is pointing to is we're pointing at multiple different spots in the immune regulatory system where multiple different places it can actually fail. And I think if it fails in any one of these places, then we're going to have some autoimmune activity similar to or the same as SLE. And ultimately what happens is I have my CD4 cell, and I have my B cell, and this cell, he escapes the central tolerance of check holds somehow. This guy, he escapes probably central and peripheral tolerance, and by doing these two things, that's supposed to be an A, by doing these two things, these guys can interact, and he can say turn on, and he can say, oh, my B cell receptors are attached, and he's telling me to turn on, so I'm going to start producing all these antibodies. And if these antibodies are self-reactive antibodies, then that means that all of a sudden I have the potential for a type 2 and a type 3 hypersensitivity, and it's going to just depend on what these antibodies bind to. Now, here's a principle. If I was just producing one autoantibody, I would expect one and only one type of hypersensitivity. But with SLE, typically you are producing tons. Well, we'll just say dozens. I can't say tons. I don't know if over the lifetime of 2,000 pounds of antibodies are produced, but dozens of types of autoantibodies. And that the reason we say it's a failure of the immune regulatory system, this is the key evidence that it's a failure of the regulatory system, and we're producing a lot of autoantibodies. So let me go ahead and give you sort of a rundown of what in my mind is happening. Now, lupus is associated with a malar rash, and it's associated with a sort of a rash due to sunlight. And so we got this sunlight coming down. This is what's happening in my mind. Sunlight's coming down. It hits poor Mike on the back of the neck, and Mike gets a little bit of rash, gets a malar rash, a little butterfly that looks more like a batty mustache, but that's my butterfly rash. And when you take a microscope and you zoom in, you just keep zooming way in, and you take a look at the cells are being damaged. So these cells, they were all good, and now they've got that sunlight on them, and they're breaking open. They're splitting open, and they're letting out nuclear contents. And those nuclear contents, they're getting picked up by the TLRs of other cells, of other immune cells, of dendritic cells, of macrophage, of neutrophils, of T and B cells. Now remember, one of the mutations, I didn't mention this, one of the mutations associated with SLE is a TLR mutation. So instead of recognizing bacterial DNA as a pathogen-associated molecular pattern, all of a sudden it's recognizing nuclear human DNA as this PAMP. The dendritic cell then goes and activates the bad T cell and the bad B cell, and now I have an autoimmune disease to anything that was spilled out of the cell, whether it be cytoplasmic or nuclear. As long as I have the B's and the T's that recognize those patterns, then I will have a proliferation, a clonal expansion, and I'll have that autoimmune disease. The big one is double-stranded DNA. That's the big one. It's the most specific for, as far as a double-stranded DNA antibody is the most specific for lupus. Now, Harrison's Internal Medicine, I think it's like chapter 270 something, 260 something. It actually lists, I think it was 13 different 13 different antibodies that are really closely linked to SLE, double-stranded DNA being the number one, but then it lists like 23 mutations in the genome that are associated with SLE, and so the mutations it lists probably being mutations within the regulatory pathway, and the antibodies it lists probably being the most common antibodies that get encountered when those regulatory pathways fail. Now, I wish I would have been given all of the organ systems, because I think all of the organ systems are pretty neat and they can all kind of be summed up and grouped together in various ways. But I was given kidney and I was given neuro, and with the background you have, you should be able to figure this out pretty easily. You have, let's get some gold on here, some gold. We have some sunlight. This is sunlight, or I could do the little jaggedy line. Sunlight, it's UV light, and it hits me. Let me make me a different color. It hits me, and I was happy, and I'm about to get sad. Because that UV light just broke open one of my cells, double-stranded DNA came out, so I have this double-stranded DNA, right? And then all of a sudden, I've already got lupus, so we've already went through the pathogenesis of it. I've already got it. I've got these antibodies that kind of just attach, right? Here's my constant portion, my variable portion, and they've attached to the DNA. And now this thing is floating around. Call this an immune complex. This is my immune complex, and it's floating around in my blood, and it gets deposited in my kidney. We're at in the kidney, specifically the glomerulus, and inside of the Bowman's capsule and the glomerulus. And where at in the glomerulus, where at in the Bowman's capsule, you ask, specifically in the basement membrane. Now, whenever these antibody complexes get deposited, they get deposited in the skin as well. In the skin, it's at the dermal-epidermal junction. In the kidney, it's at the basement membrane of whatever cells it's affecting. And you'll be happy to know that we have specific cell and specific five patterns of SLE nephritis, or SLE glomerulonephritis. We have something called minimal mesangial proliferative. Now, it could be mesangial. I've heard it both ways. I really haven't heard it at all. I'm just making it up and pronouncing it, hooked on phonics. Focal proliferative, diffuse proliferative, and membranous. So let me remind you actually what these mesangial cells are. So I've got my Bowman's capsule. Let me make that thicker. I've got my Bowman's capsule, and in that I've got some blood supply coming in. It does some loop-de-loops, and then it goes back out. Now, let me go ahead and change the color one more time. I'm going to have another cell type, like a smooth muscle cell type, right here. These are called my external mesangial, or let me correct myself, rather, extraglomerular mesangial cells. I'm just going to write MES. And then if you go inside the Bowman's capsule, you have some smooth muscle cells in there, and those are called intraglomerular. I'll just write intraglomerular mesangial cells. Now, if you have very, very few mesangial cells involved, then it's going to be this first one. And if you have a whole bunch of mesangial cells involved, it'll be the second one. And what's going to happen is this antibody dsDNA is going to get deposited in the basement membrane, and they're going to impact or affect the mesangial cells. There's actually some really good pictures of all of these different kidney things in Robbins. So I said go look at Robbins, great pictures. Next is focal proliferative and diffuse proliferative. These are just describing what percent of the glomerulus is going on. So this is describing how many mesangial cells, and this is describing what percent. So this is going to be less than 50% of the glomerulus. This is going to be greater than 50% of the glomerulus is involved in this specific nephritis. Now, you can have type 1 or type 2 by itself with no other thing, but usually if you have 3, 4, or 5, it's superimposed on top of 1 or 2. With 3 and 4, you're going to get fibrinoid necrosis, endothelial proliferation, infiltrates, and thrombi. Now, you might not get all of these, but you'll get you'll get some of this if you have type 3 and type 4. So fibrinoid necrosis, endothelial proliferation, infiltrate, and thrombi. Those are the things with 3 and 4. Then finally, part 5, membranous. Now remember, I think the books typically say that number 4 is the worst. I don't know why 5 isn't the worst. It just doesn't make sense to me. Maybe it is, and maybe I'm reading it wrong. I'm just saying what I understand right now, number 4 is the worst kind of thing we can have. And then number 5, this is just simply a thickening. Here, let me write this over here. This is a thickening of the capillary wall. Thickening capillary wall. And it's going to have nephrotic syndrome. So, nephrotic syndrome. Thickening of the capillary wall with nephrotic syndrome. Remember, that's going to be called membranous nephritis, membranous glomerulonephritis. This is a part of the kidney disease with SLE. And before I go on to the neuro, I just want to say kidney is typically the reason people die with a lot of autoimmune diseases, and SLE is not an exception. Kidney kills. So, like with the number 4 pattern, where you had diffuse proliferative nephritis, it was greater than 50% of the glomeruli. You might remember that you can live with one kidney. That's why donating a kidney isn't bad, but it's really hard to live with like half a kidney. So if greater than 50% of your glomeruli are poisoned with SLE, with these antibody complexes, then your kidney's failing. And that's, of course, why it's the worst, but I don't know why it's a 4 instead of a 5. Like, why don't make it 5? Now, neuro is easy because the answer of why neuro and what neuro, you get a lot of different neuro signs. You can have psychiatric, you can have like neuropathies and stuff like that. They can be focal, they can be diffuse. And here's the thing, nobody knows what causes them. So we're already done. But I'll go ahead and give you a few of the kind of ideas. Okay, so first of all, first idea, maybe there's an antibody against synaptic membrane proteins. These have been found in some cases, not in all cases. So maybe this is one of the many causes of the neuro pathology. Or maybe it's not at all. I don't know. The second thing is it could be occlusions of the small vessels. So why am I not, like everyone knows that lupus is associated with vasculitis, and why am I not just saying vasculitis? Because that's what the book says, it's not vasculitis, and vasculitis is not really found in the CNS of people that have lupus on autopsies. But sometimes maybe there's occlusions of the small vessels, and there's a mechanism for this. The mechanism for this is called intimal proliferation. The intimal proliferation could be caused by antiphospholipid antibodies. You've probably heard there's an autoimmune disease called antiphospholipid syndrome. I think the big antigen there is the anticardiolipin, and it's probably a high-yield word. I don't really even know what it means right now. I haven't looked it up, but anticardiolipin, and that's antiphospholipid syndrome, and that those antibodies are also sometimes made in lupus. Like, it's, I think 30% of patients with lupus. I'm pulling that number out of my butt, but I've heard like 30 or 20. I heard one of those numbers, but I'm going to say 30% of lupus patients have antiphospholipid syndrome. Okay, I just explain myself. Why am I pulling numbers out of the air? Because I did a lot of reading on this before I ever started like putting my objective together, and I just really wanted to understand it better for myself. And some of the things I took notes on, and if they looked important to me, some of them I didn't. That didn't look important to me at the time, but like now that I'm talking, like wait, that's important. That number's probably important, I'm guessing. Anyhow, that's the neuro. We really don't know why. There's two ideas. One's like an antiphospholipid syndrome type of aggravation that causes proliferation of the intima, and the other one is that there's a antibody against synaptic membrane proteins, and maybe both of those things are true, and maybe none of them are. Now's the time where I scroll through the credits. I did big Robbins Big Robbins, mostly I did page 211 through 218 for the SLE stuff, and chapter 27 for all the other neuro autoimmune things that I threw in there. Harrison's, chapter 378, it was all SLE for those 11 pages. Najib lectures, I rewatched the lecture on hypersensitivity. Pathoma, I watched the lecture on autoimmune. Wikipedia, probably looked at it a few times. Pathophysiology for health professions, it didn't add anything useful to my knowledge. My roommate did have a few of her books that were on pathophys that I also looked at, but I don't remember the exact title of those books, and they added a little bit, they simplified things for me to understand it better, but they didn't add really anything to the content.